Okay, let's tackle question 2 now. The question is that this is a Cournot game with two firms, firm 1 and 2. There's an inverse demand equation which looks like this: P of Q equals 60 minus capital Q, where capital Q is total quantity in the industry. It is small q1 plus small q2 if capital Q is less than equal to 60. Otherwise, this inverse demand is 0, not negative. Firm 1's total cost is commonly known to be, so C1 is equal to C1, is just equal to Q1, and C2 can be C2 can be either equal to Q2, or it can be equal to Q2 squared, each with a probability 0.5. Right, so there's a 50% chance that the cost of the second firm is just Q2, and there's a 50% chance that the cost for the second firm is Q2 squared. Now, firm 2 privately knows which of these two her cost is. So firm 2 knows her own cost. Firm 2 also knows firm 1's cost. Firm 1's cost is common knowledge. Firm 1 knows her cost, which is Q1, but doesn't know what firm 2's cost is. Firm 1 only knows the probability, the likelihood that Q2 has a high cost versus a low cost. Okay. The first part is write out the profit function for firm 1. Okay. So I'm going to call the quantity that firm 2 chooses in its low state Q2L, and quantity that firm 2 chooses in the high cost state Q2H. Okay? So firm 1's profit will simply be, with a 1/2 chance firm 1 is facing a firm 2 with a lower cost, and so with a probability 1/2, the price is 60 minus Q1 minus Q2L. You have this price, you multiply this to get the total revenue in this chance, plus with a probability 1/2, this is the price, 60 minus Q1 minus Q2H times Q1, and the total cost is just going to be Q1, right? So this part here is the expected value of the total revenue, right? Because with a 1/2 chance you get this as total revenue, with a 1/2 chance you get this as your total revenue. Your total cost, well, this you know, right? This is the expected value of total revenue, and this is the total cost. I've written it out slightly differently in the solution, but I think this makes more intuitive sense, just the way of writing this down. This, of course, will simplify, and you guys are perfectly capable of doing algebra. I'm just going to write out the profit for firm 2 now. I have to write it out for each type of firm 2. So, bear with me, pi to L equals, the total revenue will just be 60 minus Q1 minus Q2L times Q2L, and its total cost will just be Q2L. This is the profit function for the firm when its cost is simply Q2. For Q2H, all I'm changing is this here. So total revenue changes to this, but total cost is Q2H whole squared. Right? Now with each of these profit functions, you can take first order conditions to get best responses. And my guess is that that's what we're asked to do next. Give me 1 second. Yep, I am that predictable. So that's what I've asked you to do next. Take first order conditions. Now, let's do it for the first term because that's the harder one. So pi 1 had simplified to 59 minus q1 times q1 minus q1 times q1 divided by 2 times q2l plus q2h. Okay, so this is just me simplifying things. When you take the first order condition for the first term, del pi 1 del q1 should equal 0, and that implies that you get this equation where 59 minus 2q1 minus 1 half q2l minus 1 half q2h equals 0. So you can write q1, which is the best response of firm 1 to q2l and to q2h, equals 29.5 minus 1/4 of q2l plus q2h. Right, so all this is pretty standard. We're just taking a partial derivative of firm 1's profit function with respect to the quantity that firm 1 chooses herself. We do the same for the other two firms. We get FOC for firm 2 type L and the FOC first order condition for firm 2 type H. Those will look simpler because, well, Q2L equals 29.5 minus 0.5 Q1 and Q2H equals 15 minus 0.25 Q1. And then in equilibrium, what we have simply is 3 equations and 3 variables, and so we can calculate out the equilibrium values of Q1, Q2L, and Q2H. With 3 linear equations and 3 variables, what I find super easy is substitution, and so that's what I did. And so I got Q1 star equals 294 divided by 13, which approximates 22.62. Q2L star equals 473 divided by 13, which approximates, 473 divided by 26, which approximates 18.19. And Q2H star equals 243 divided by 26, which approximates 9.35. So if you compare it with a situation where firm 1 had perfect knowledge, and if firm 1 knew that firm 2 has a lower cost, then firm 1 would be making a lower quantity and firm 2 would be making a higher quantity. And if firm 1 knew that firm 2 had the high cost, then firm 1 would be making a higher quantity and firm 2 would be making an even lower quantity. So this type of firm 2, the firm 2 that has the higher cost, is actually benefiting from the chance that it might have a lower cost, and the firm 2 that has the lower cost is losing out by being lumped in with this other firm. And so that's an interesting dynamic that plays out here. Now, once you have all of these costs, these quantities, you can calculate price, which is just 60 minus Q, The price will be different when the state of the world is L or the state of the world is H. So depending upon whether the firm 2 has a lower cost or a high cost, the price is going to be different, and therefore the profits of each firm are going to be different as well in both of these worlds. And I can just give you my solutions, I guess, since you have, so that you have the solutions all in one place when you're comparing. P in the L state equals 19.19, P in the H state equals 28.04, pi 1L equals 411.46, pi 1H equals 517.89, pi 2L equals 349.15, and pi 2H equals 174.72. Again, all of these are approximate. There were fractions, and most of them had to involve dividing by 13, so these are all approximations to 2 decimal points, which is what I want you guys to do in the final exam as well. Just approximate everything to 2 decimal points. Okay, I'll do question number 3 in the next video. See you there.